Good morning, viewers. Welcome to my YouTube videos on high physics norms.
Hello, good morning students. Today I would like to discuss about the topic electricity. In this electricity is very useful to learn this. It will be helpful for 9th class students and 10th class students and plus 2, that is 12th class students. It is very helpful. Now we are going to discuss about the fundamentals about this electricity concept. Before going to discuss about this, you have to know the fundamental things, just like battery. So battery, how can you give a symbol of a battery? Generally battery symbol will be like this, big line and small line. This indicates, the big line indicates the positive terminal, this indicates the negative terminal. This is the fixed type of battery. If the battery will be like this, 1 2 3, like this combination of so many batteries, positive and negative, this we can call as variable battery. That means we can change the potential, or you can write like this. You can draw the diagram for the battery, variable battery, like this also, by keeping a arrow mark here. This also indicates the variable battery type. So this is a symbol for the battery. This is in the DC circuit. So DC stands for direct current. For the AC, as you know, that is in the reverse order. If for AC, the symbol will be like this. This is the symbol of AC. This is the symbol of DC. Okay, this is the symbol of battery. Now, in general, we are using the batteries in so many electronic devices, just like a TV remote control is there, or a watch. In the watch, the cell is there. It is also a battery. Generally, those are of capacity 1.5 volts capacity, that battery capacity is. Now next will be, after this battery, you have to know wire. Generally copper wire is used in the electricity point of view. Copper wire and that is aluminum wire is used in general for producing the electricity. Say those are the good conductors of electricity. So that means in electricity, basically the electricity is nothing but a combination of two parts. One is electrostatics, that is static electricity, and another is the current electricity. So how can you vary these two? So if it is the static electricity, means if the charge is in the rest position, it will produce only electric field around that. That we can known as static electricity. If the charge is in the motion, then it will have both electric and magnetic fields. That is about the current electricity. So current, so what do you mean with the term current itself indicates? How can you define the current? So the basic thing for the current is C-U-R-R-E-N-T, current. The symbol generally is I. So how can you define the current? So charge flowing per second, or simply you can write it mathematically, dq by dt. So Q stands for charge. Here you can say that simply you can say Q by T. Directly you can write. For small quantities you can use dq by dt. For the large quantities you can use Q by T. So where Q stands for charge. So generally the unit of charge is, it can be measured in coulombs. Symbol is C. In general we can use in a mathematical point of view, that is in the problematic point of view. Coulombs generally used in micro coulombs. Micro stands for mu, which is nothing but 10 power minus 6. And nano coulombs. Nano means 10 power, so symbol will be small n, that is 10 power minus 9, and is pico, that is small p, the value is 10 power minus 12. So micro coulombs, nano coulombs and pico coulombs, generally they use these values. Now charge means we can get the electron. So electron is a negative charged particle. So what is the charge of electron? Generally we need all these values. So charge of electron is generally, it is a negative charge. Charge of electron is equal to, simply symbol E bar, E power, if you can put a dash here. So charge of electron is in general 1.6 into 10 power minus 19. As you know, the unit of charge is coulomb, that is C. As mass of electron, that is around 9.1 into 10 power minus 31 kg. Somehow you can do specific charge, you can say specific charge, that is E by M, you can say. So if you divide this, you will get 1.76 into 10 power 11 coulomb per kg. So these are the values we required while doing the problems. So this is about the electron, and the charge is there and current is there. Now what are the units of current? Simply you can say units of current. You can say simply coulomb per second you can use, or another unit is ampere. Simply A, or simply amp. So this is the ampere symbol, current symbol. So how can you measure the current? Generally for measuring the current, the instruments are used ammeter and the galvanometer. So what is an ammeter? So we go for the ammeter. So what is an ammeter? Ammeter is a device which is used to measure the current. So generally ammeter will be looking like this. In between them A will be there. You have the readings here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it is arrow mark is there. So this is a symbol of a ammeter. In general, in lab point of view, they will be available ammeters are a microammeter, milliammeter. So ammeter is also there. So that is about the ammeter. So what about the galvanometer? Galvanometer is also an instrument used to measure the current, GALV, or simply you can use G. So galvanometer is an instrument which is used not only measuring the current but also give the direction of the current also. Galvanometer. So here needle arrow mark should be at the center only. 0, 1, 2, 3, 4, 5, some dash dash 1, 2, 3, 4, 5 like this. That means arrow mark always at the center only. If the direction of current is one direction, it will the needle will deflect in other direction. If the direction of current is in the other direction, the needle will be in the other direction. That means galvanometer not only measuring the current but also measure the direction of the current also. Generally for the nano amperes, that is NA, nano amperes of current, that is around 10 power minus 9 amps of current. That small amount of current can be measured by using this galvanometer. So that is the basic, that is the difference between the ammeter and galvanometer. Some other things also there. So basically these are two used in the laboratory point of view. So next will be here in fundamentals. So you have to know some other thing is potential. So what do you mean by the potential? So potential, other topic is potential. So symbol will be V. In some cases it is also known as voltage also. Voltage or potential, both are similar terms. Now how will you define the potential? So the simple definition for the potential is, say for example, if a charge is there, that is in general in the definition form of view, we can use a unit charge. Say for example, a unit charge is there, that is represented with the symbol of Q naught. Now, if you want to bring the unit positive charge from infinite to at a particular point, then if you want to bring from infinite to at a particular point, the work must be done here. That bringing of work done is to bringing up the unit positive charge from infinite to at a particular point. The work done is nothing but potential. Simple definition of the potential is amount of work done to bring unit positive charge from infinite to at a particular point. Particular point is known as potential. This is a definition of the potential. So first of all, you have to know that what is a infinite and what is a finite. Infinite in the sense that is from America or Japan or some other place of Jammu, Kashmir, or you can say Kanyakumari, like that. That is not the infinite in the sense. In physics point of view, there is a small difference between the finite and infinite. Infinite in the sense, say for example, this is our classroom. In this classroom, each and every object can be considered as finite thing, as we know this. This is about the finite. So that means this is a lab. Within the lab, each and every particle it can be considered as finite things. Just outside the lab, say for example, outside the building, outside our classroom, that can be considered as infinite thing. So that is the basic difference between the finite and infinite. Infinite means outside the lab. Finite means inside the lab. That is the basic difference between the infinite and finite. Now, the definition of potential is amount of work done to bring the unit positive charge from infinite to at a particular point. That is called the potential. You can write it mathematically. Work is there. So, W is equal to W by Q. This is the formula for the potential. V is equal to W by Q. Or you can write for this units will be, as usual, work means joules, charge means second, joule per second. Another unit for this potential is volt, or simply V. This is the definition of potential. Now, from this, another definition we can observe, that is potential difference. Or simply you can say P. Same symbol. Now, in this definition, a slight change will be there. That is, amount of work done to bring unit positive charge from one point to another point. Here, infinite at a particular point. Here, in this case, difference means two points should be present. That means you can write simply amount of work done to bring unit positive charge from one point to other is called potential difference. Say simply, for example, these are the 2 points A and B. Now I would like to bring the unit positive charge from B to A or A to B. That potential difference, say for example, VAB, is nothing but difference. That is VA minus VB. This is the potential difference. Okay, got it? So same units, same dimension formula, same everything will be same for potential and potential difference. The difference is difference only. Okay, later this is about the potential topic. So I have completed here current definition and potential definition. Now, to what is the relation between these two? That can be explained by Ohm's law. So now we're going to the topic. What is Ohm's law? Actually, Ohm's law is not a fundamental law. It is an empirical law, we can say. So what is the difference between the fundamental law and empirical law? So fundamental law means the relationship between the fundamental things. Empirical means some derived quantities relation. So we go for the Ohm's law. Ohm's law. So according to the Ohm's law, here the main condition you have to remember is temperature. Here temperature should be constant. So we can say simply, initially you can say at constant temperature. This is important. At constant temperature, potential difference applied between the conductor is directly proportional to current passing through the conductor. You can write it. The potential difference across a conductor is directly proportional to current passing in the conductor. So as we know that conductor means which will allow the flow of electricity is called the conductor. Example, all metals including the human body also. Whereas insulator means which does not allow the flow of electricity, which we can call as insulators. The example for this is rubber, plastic, wood, etc. So some another is also there is semiconductor. Semiconductor means the intermediate properties of conductor and insulators. That is called the semiconductors. So when and where the semiconductor behaves like an insulator, say like a conductor, that means we can say that at a normal temperature, So okay, that is another topic we discuss it later. So this is about the Ohm's law. How can you write it mathematically? So potential difference, or simply you can say V delta V also you can write V proportional to I. This is Ohm's law. Here this is important, constant temperature. That means at a constant temperature, potential applied to the conductor is directly proportional to current passing through the conductor. This is called the Ohm's law. Or you can simply, to remove the proportionality, a constant is introduced which we can call as R, or you can call as resistance of a conductor. This is the proportionality constant. So or you can simply write that R is equal to V by I. That means R is not directly proportional to potential. Okay, remember this. So R is a constant. It depends on the nature of the material we can take. That is depending on the metal. That is copper or aluminum, whatever it may be. Now you can write the graph between them also. Why? Because potential directly proportional in the sense, the simply you know that the graph between them is, if you take potential on the x-axis or current on the x-axis, potential on the y-axis, V is directly proportional means that is a straight line passing through the origin. This is a graph which is called the ohmic device graph. Potential and current, though both are directly proportional means a straight line passing through the origin. This is the graph between V and I. Okay, this is in the x-axis you can observe, this is in the y-axis. Now basing on this, ohmic conductors and non-ohmic conductors, two types are there. Ohmic conductor means which obey the Ohm's law is called ohmic conductor, and the device is called the ohmic device. Example will be metals. The non-ohmic devices or non-ohmic conductor means the conductor, the device which does not obey the Ohm's law is called non-ohmic device, non-ohmic conductor. That is best example is the semiconductors like diodes, triodes, transistors, etc. So this is about the basic of the Ohm's law. Now continue to this R. Yeah, this is very important. Say for a observation, R stands for resistance of a conductor. Now we go for the symbol resistor. Resistor, what it will do? Resistor. So what it will do? See, resistor. Resistor having resistance. Similar to this, capacitor having capacitance, inductor having inductance, turtle having tenses. So that means here resistor having resistance. What it will do? It resists the flow of current. What it will do? It resists the flow of current. Now, how can you symbol for this resistor? The symbol for the resistor will be like this. Okay, this is a symbol for the resistor R, and the units for the resistance is ohms. Now the symbol will be like this, ohms. Now how can you in general the resistors will be so many different types. For example, in general, we can use the resistors, the symbol, the looking like this. Resistor will be looking like this. It will having some colors. So by knowing the formula of color code, we can determine the resistance of the given resistor. Okay, now resistor. So resistor depends on what factors we have to know. So see here, resistance of resistor or conductor, resistance of a conductor, we better use this. Depends on what factor it will depends. Depends on number one, length of the conductor, LNGTH, L. Number two, area of cross section. Number three, temperature. Number four, nature of material. On these four factors, resistance of a conductor will depends. Now, how can you do this? Say for example, resistance of the conductor is directly proportional to length of the conductor. That means more length, more conductor, more resistance will be there. Less length, less resistance will be there. And resistance of a conductor is inversely proportional to area of cross section. Say for example, two persons are there. One is a lean person, that is thin person. Another is the heavy fat person. Both are running. So who will come to rest first? So in general, we can say, don't think that thin person having the high power and a fat person having low power. Just for the example point of view, that means low, which is a heavy fat person, will move for less distance only. Why? Because his restive power is very less. If it is a thin person, he jumping, he will move more distance comparing with the fat person. That's why in general we can say, but in a physics point of view, so this is also best example for this. More length, more resistance, less length, less resistance. So area means more area, less resistance, less area, more resistance. That is, this is inversely proportional, this is directly proportional. Now we can get the relation between them. That is, R is proportional to L by A. Again, proportional is there. That means, if you want to remove the potential, we can use the constant. That is, R is equal to rho L by A. In some books, S L by A is also. Rho R S, whatever it means. Now, this rho is called, rho R S is called, we can say this is resistivity. You can say this is resistivity. Or you can say specific resistance. Both are same. Resistivity or specific resistance, we can say. Now, this resistivity is depends on the nature of the material. It is a fixed value for any material. Not any material. For copper, it is a fixed value. For aluminum, it is a fixed value. That means it is a constant for the material. So this is about the specific resistance. Now, go for this specific resistance. So R, rho is equal to, from this I will get the formula, rho is equal to RA by L. You can get the formula. So the units as usual, how can you write the units? Ohms. Area means meter into meter, length into breadth. Length means meter. So 1 meter cancels, simply ohm meter is the unit of specific resistance or resistivity. Or another unit is Simon is the another unit of specific resistance. It depends on the nature of the material. Okay. Now from this you can write the double action formula is also there. So for example, same formula if you use, R is equal to rho L by A. If the materials are different materials, you have to find the resistance ratio. We can use the formula R1 by R2 is equal to rho 1 by rho 2 into, you can use L1 by L2 into area down is there. That means A2 by A1. This is one formula. If the rho is constant means same material means you can simply use R1 by R2 is equal to L1 by L2 into A2 by A1. This is another formula, simple formula to find the new resistances. So here very important point for this finding the resistances. Say for example, if a wire is there whose having the length is L and the resistance is R, example. So resistance is R, length is L. It is stretched itself. So stretched itself, and the length becomes L2. This is L1 length. Length becomes L2. So this is R1 resistance. What about the new resistance? That is the question. That means if the length, the stretched by itself, in the sense volume here is constant. This is important. in a question, if they given volume constant word is given, simply we can use the formula R is proportional to L square. That means in the double action you can use R2 by R1 is equal to L2 by L1 whole square. This is very important formula. You have to remember this. Okay. The next, resistors. Resistors connected in series, connected in parallel. How can you explain this? Okay, first one, resistors connected in series. So let us consider n resistors having the resistances R1, R2, R3, so on and Rn connected in series like this. These are the let n resistors of resistances R1, R2, R3, dash 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 Rn are connected to a battery of potential V. So that can be draw the diagram, circuit diagram you can say. These are the resistors. So 1, 2, 3 and so on n. These are connected to the battery. Symbol battery, as you know, plus minus. This is the potential is given V. Now these are the having resistances R1, R2, R3 and so on Rn. So these are connected in series. Series connection will be like this. Okay. Now in series connection, you have to remember that very important point. In series connection, potential will be changing, current is constant. Remember this. If they are connected in series, automatically potential is there, means current will passing through the circuit. That is, current is constant. Here, current I is constant. Potential will be changing. Now, potential changes. That is across R1, V1, V2, V3 and so on Vn. Now potential changes. As you know that potential is equal to, what is the formula? Potential V is equal to, according to the Ohm's law, IR. Here these are connected in series. Simply you can say IRS. RS brothers. RS. So total potential. Can write total potential V is equal to V1 plus V2 plus V3 plus dash 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 plus Vn. As we know the formula, V is equal to IRS. V1 is equal to IR1. V2 is equal to IR2. V3 is equal to IR3 and so on. Why? Because in across every resistance current is same. That is constant, that is I. You can substitute here IR1 plus IR2 plus IR3 plus dash 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 IRN. So simply I take out the I as the common. IRS is equal to I is common. You can write R1 plus R2 plus R3 plus dash 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 plus RN. I cancelled. RS is equal to R1 plus R2 plus R3 plus dash 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 plus Rn. So for if R1 is equal to R2 is equal to R4 is equal to dash 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 is equal to Rn is equal to R, that means all are equal resistances, same resistances, then simply you can write Rs is equal to Nr. This is very important, you have to remember. Say for two resistors, you can say R is equal to R1 plus R2 if they are connected in series. This you have to remember the formula for doing the problems. So this is about the resistors connected in series. Okay. Next will be resistors connected in parallel. How they are connected in parallel? Okay. So let us consider n resistors of resistors R1, R2, R3, R and dash are connected in parallel. Connected in parallel. Connected in parallel. How they are connected in parallel? Okay. So parallel connection will be like this. So these are resistor number 1, number 2, number 3, dash, number n. Okay. All the first terminals. This is the first terminal, this is the second terminal. 1, 1, 1, 1. Second terminal, second. Now all the first terminals are connected to one end. Okay. And all the second terminals are connected to other end. Okay. Now these two ends are connected to the battery of potential V. Okay. This is the parallel connection. Remember this. All first terminals are connected to one end. All second terminals of the resistors connected to other end. These two ends are connected to the battery. This is called the parallel connection. So you can write it in matter form also. So better to write in connected in parallel to a battery of potential V. Okay. Here, these are the named R1, R2, R3 and so on, Rn. Here, in previously, if the series connection means, here, in the series connection means current is constant. What about in the parallel connection? Basically, you have the three terms, potential, current and resistors. Resistors here already connected to the battery of potential. So what about the current? Here, in this case, current is changing, potential is constant. So remember one thing, that very important thing. If resistors, capacitors, inductors, whatever it may be, electricity bulbs, whatever it may be, if they are connected in parallel, potential remains constant. Remember this point, parallel, potential constant. You can remember this 5 times easily. For parallel, potential constant, parallel, potential constant, parallel, potential constant, like that. Okay. Now, parallel means potential constant, as you know. So that means here also potential V. Potential constant. R is changing. What is the other term? Current. Current obviously changing. That is current I here. It will be divided like this. In the first resistor, current is I1. In the second, I2, third, I3 and so on in Rn, In. That means potential constant means we cannot determine the total potential. Total potential itself is nothing but the V only. Okay. That's why if you observe remote cells or AC cells, whatever it may be, there is a remote, using remote, the batteries 1.5 batteries is there, na? Those are always connected in series only. That means plus is connected to minus, minus is connected to plus, if you observe that. Okay, that means they are in series. Why? Because if the two cells, generally they are connecting two cells, so two cell series means 1.5 plus 1.5, that is 3 volts. What happened if they connected in parallel? Simply 1.5 volts only. There is no use of connecting that. That's why here parallel means potential is constant. Remember this, parallel means potential is constant. Now I want to find the total current. So what is the general formula for the current here? So current I parallel IP is equal to, what is the formula? V is equal to IR. V is equal to IR. I is equal to, what you can write? V by R. Parallel means RP. So potential constant. So total current IP is equal to, you can say that, or I is equal to, simply you can say I1 plus I2 plus I3 plus dash plus IN. As we know the formula, apply here. V by Rp is equal to V by R1. Across this V by R1, V by R2, V by R3, and this is V by Rn. Plus V by R2 plus V by R3 plus dash 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 V by Rn. Now take out the V as the common. V as the common 1 by R1 plus 1 by R2 plus 1 by R3 plus dash 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 plus 1 by Rn. That means we cancelled, we will get 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus dash 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 plus 1 by Rn. This is the formula for the resistors connected in parallel. If all resistors of equal value, what happened? See, if R1 is equal to R2 is equal to R3 is equal to dash 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 equal to Rn is equal to R, then what happened? 1 by Rp is equal to N by R, or simply you can say Rp is equal to R by N. Rp is equal to, you can say, R by N. So for two resistors, you can use 1 by Rp is equal to 1 by R1 plus 1 by R2. Okay, or simply you can say, simply you can say Rp is equal to, take out the LCM, R1 R2 by R1 plus R2. This is important. While doing the problems, if they given two resistors connected in series and then parallel, what is the effective values of the resistors? Such type of questions, you can use the mathematical formula, that is A minus B whole square is equal to A plus B whole square minus 4AB. In place of AB, you can use R1 R2. That means, so you can put it in the note, R1 minus R2 whole square is equal to R1 plus R2 whole square minus 4 R1 R2. This is important formula while doing the problems. Okay, this is about the resistors connected in parallel. Previously, resistors connected in series. So we can do some problems related to this. Okay. See some problems. Yeah, problems. So if two resistors, example number 1, two resistors of resistances 4 ohm and 6 ohm connected in number 1 series, number 2 parallel. Find effective resistance. So it's a simple problem. Okay, two resistors. Number A, first bit, series. You can write series like this. Yeah, R1 and R2. So the values given here is, this is 4 ohm, this is 6 ohm. They are connected in series. What is the value of series? Rs is equal to, you can simply write R1 plus R2. That is 4 plus 6 is equal to 10 ohms. Answer is 10 ohms. Number 2, if they are connected in parallel. Parallel means like this. First terminals connected to one end, second terminals connected to the other end. So this is 4 ohm, this is 6 ohm. So what is the effective value? Rp, as you know that. You can write two problems, R1 R2 by R1 plus R2, or you can use 1 by R is equal to 1 by R1 plus 1 by R2, whatever you want. So simply R1 R2 by R1 plus R2. So as you know, 4 into 6 by 4 plus 6, that is 4, 6 ja, 24 by 4 plus 6, 10. That is simply 2.4 ohms. So this is also a small problem. If in the question, they will ask like this. Example number 2. Here, this is a small circuit. Yeah, Yeah, 2 ohm, 3 ohm and 6 ohm. Let us see A and B. If the circuit is like this, what is the effective resistance between A and B dash? If the question is like this, so how can you do the problem? Simple manner. Say these two are parallel, the upcoming value and this value is in series. You can reduce this. How can you do this? Simply I can redraw the circuit once again. 2 and 3 are parallel. Parallel means what is the condition? RB, R1 R2 by R1 plus R2. That is, simply you can say that here 2 into 3 by 2 plus 3. That is 6 by 5 ohms. 6 by 5 ohms is the effective value. Now the 6 by 4, 5. So you can write once again 1, 2, A, B. This total value, how much? 6 by 5 ohms. This value is 6 ohms. Now these two are in series. Series means simply addition. RAB is equal to R1 plus R2. That is 6 by 5 plus 6. So what you will get? 5 is the LCM. 6 plus 5, 6 is 30. That is 36 by 5 ohms. In this way you can do series and parallel combination. Okay. So these are some small problems. If suppose some other problems are also there, like, okay, for example, this is an example, another example question. Okay. Say for example, if the circuit is looking like this, two resistors, 5 kilo ohms, 7 kilo ohms, connected to the battery of potential 15 volts. Then what is the current in the each resistor? Or you can use current in the circuit. Each resistor means why because those are connected in series means current should be same only. So you can write here these two are connected in series. For this circuit will be changed to like this simple circuit. This is 15 volts. These two are series. Series means, as you know, the formula for the series is R1 plus R2. That is 7 plus 5. 7 plus 5. That is how much? 12. That is 12 kilo ohms. This is 12 kilo ohms. Potential is here. So from the circuit I can know the value of R is equal to 12 kilo. Kilo in the sense 10 power 3. Then the potential is 15 volts. As you know, from the according to the Ohm's law, V is equal to IR from Ohm's law, or I is equal to V by R, or simply 15 by 12 into 10 power 3. So 3 4 ja, 3 5 ja. Okay. 5 by 4. 5 by 4 in the sense, how much it will be? 5 by 4 means 4 1 ja, 4. 1 0 10 4 2 ja 8 4 5 ja 1.25 into 10 power plus 3 becomes minus 3. Current unit is amps. Simply you can say 1.25 milliamps. This is the current in the circuit. So this is the combination of resistors and the potential. Okay. Next, for the resistivity also you can get the problems. Resistivity problems also there. So if for example 4 physical terms are there, if 3 are given, you have to find the fourth term. If 3 are there, 2 are given, third you have to find by using the formula as usual. So next here Kirchhoff law. After this you can get Kirchhoff law. So what is Kirchhoff laws? Kirchhoff laws. Kirchhoff laws. Two laws are there. Kirchhoff explains the two laws. One is related to the current, another is related to the potential. That is, first one is Kirchhoff current law, Kirchhoff voltage law, another law is. So first we go for the Kirchhoff current law. Kirchhoff's current law, or sometimes this is also known as junction law. So according to this law, here is a junction. Let us say train junction is there, Hyderabad is there, Hyderabad is a junction. In that junction, so many trains coming and some trains will going away from the junction, coming towards the junction. So if it is a junction, I am considering, let us say, two trains are there. Two trains, these are coming towards the junction, that can be represented by the arrow mark. Some other three trains are there which are moving away from the junction. Current, now all are current train, power trains only. That is I1 and I2 are the incoming currents. I3, I4 and I5 are the outgoing currents. This you can call it as the junction. So simply the statement given here is algebraic sum of currents at a junction is equal to 0. This is a simple statement. Algebraic sum of currents at a junction is equal to 0. This is about the Kirchhoff current law. It obeys law of conservation of charge. So all we hear that law of conservation of energy. What is law of conservation of charge? Same thing here. So according to in the mechanics, law of conservation of energy means energy can neither be created nor be destroyed, but it can change from one form to another form. Whereas in this law of conservation of charge means charge can neither be created nor be destroyed, but it can transfer from one part to another part of the body. So one part to another part. Or you can say law of conservation of charge. That means it obeys law of conservation of charge. That means charge can neither be created nor be destroyed, but it can transfer from one body to another body. This is a correct one. Okay, this is about the law of conservation of charge. Now mathematical can write incoming directions can be considered as positive, outgoing considered as negative. That means you can simply algebraic in the sense I1 plus I2 minus I3 minus I4 minus I5 is equal to 0. Or else in other words you can write like this also. I1 plus I2 is equal to I3 plus I4 plus I5. Or simply you can say incoming sum of the incoming currents is equal to sum of the outgoing currents. So this is about the Kirchhoff current law. So for this we can do the example one. Problem also no problem. So for example like this, like this, like this, like this, like this, like this. So these are the Z junction. See here, this is 20 amps current. Here is 6 amps. Here is 2 amps. This is arrow mark 5 amps. This is some 3 amps. What about the value of this one? If the circuit is like this, what is the value of I? That's the question. Okay. Now how can you do this? Simply 20 amps current is starting here. Here 6 amps will be gone. Here 2 amps will be gone. How much will be here? 20 minus 6 minus 2. That is 20 minus 8. That is how much? 12. This is 12 amps. 12 amps, 5 amps will be incoming. That means 12 plus 5. That is how much here? 12 plus 5 means 17 amps. Okay. Among 17 amps, 3 amps will be going in that side. What about this value? Simply you can say that 17 minus 3. That is how much? 14 amps. So the current here is 14 amps. Small problems, simple problems we can do by using this Kirchhoff junction law or current law. Okay. Next, Kirchhoff's voltage law. Okay. Kirchhoff's voltage law. Voltage law, or you can say this is also loop law. Loop means starting and ending point should be same. Here I am considering some resistors in a simple manner. Say resistors having the resistances R1, R2, R3 connected in series to a battery of potential V. This we can call as a loop, closed. So plus whenever it is connected to the battery, the current will passing like this and passing through the R1, R2, R3 and return back to the negative terminal. That means a loop will be completed there. That means current will pass through this circuit. This is a loop. So you can say simply the statement for this will be algebraic sum of potentials or voltages. Potentials in a loop is equal to 0. Or here it obeys law of conservation of energy. Why? Because potential is there means already we know the definition of potential, walk by charge, work is there, work means energy is there. Simply remembering point of view. So it obeys law of conservation of energy. Whereas in case of current law, it obeys law of conservation of charge. Here it is in the law of conservation of energy. Got it? So it obeys law of conservation of energy. So from this, I can find the current in the circuit also. That means series connection means current is constant only. So you can apply the law here, voltage law. That is loop means starting. So R1 according across this R1 potential will be how much? IR1, and across this R2 plus IR2, R3 plus IR3. Here is minus V is equal to 0. From the circuit I can write the formula. So take out that I, take out the common, R1 plus R2 plus R3 is equal to minus V becomes plus V. That is current I is equal to V by simply R1 plus R2 plus R3. So this is the current in the circuit. This is about the Kirchhoff laws. Kirchhoff current law and Kirchhoff voltage law. Okay. Later, so we can continue in the next class. Remaining topic. One thing. Before closing this topic, you have to how you can determine the resistance of a resistor. That is by using the color coding method. Generally, this is used for plus 2 point of view. That is 12th class students. For 10th class students, not in the syllabus, I think. Even though you can easily, you have to know that. Okay. So that is color coding. Color coding. So color coding, very easy method. See, for example, in a resistor in the market, the resistance availability will be like this. The shape will be like this. It consisting of so many colors. So 1, 2, 3 colors, and some fourth color will be also present. So for this, the formula for finding the value of this one is formula. That is first color side by second color, not multiplication, just keep inside. Second color into 10 power third color plus or minus tolerance. This is the formula to find the resistance of the given resistor. Very important formula. Once again, I would like to repeat this. First color side by second color into 10 power third color plus or minus tolerance. Tolerance means depending on the silver or gold, or if it is no color is also for tolerance will be there. So for this easy point of view, you can remember this B.B. Roy. B.B. Roy, Great Britain, very good wife, wearing gold silver necklace. Easy method, remember this. B.B. Roy, Great Britain, very good wife, wearing gold silver necklace. So in general, all colors will be present in the black and white. So in between the black and white, you can have the colors for the remembering point of view. That means first B stands for black color, and this W stands for white color. In this one, black and white, remaining colors will be present. Nearby the color of black is, as you know, brown, and then red, orange, yellow, green, blue, violet. Nearby the white, gray. Remember this. So first value 0, starting 1, 2, 3, 4, 5, 6, 7, 8, 9. Gold. For this gold tolerance should be 5%. Silver 10%. If no color is given, that means simply 20%. This is about the tolerance. Okay. This is the formula for determining the color coding. So for example, our Indian flag is there. Say our Indian flag. So for only example point of view I am considering here. Don't think that it's other thing. So for Indian flag, what are the colors you have? One is you can use brown. Okay, red color is there. Let us assume not red. So red is there, and then white color, and then green color. Okay, this is, say for example, gold. Okay, red color, white color, green and gold. These are the colors given to the resistor. How can you find the value? See, from these values, here from left you can use red color. Red color in the sense, what is the value of red color? 2. Yeah, first color is 2 1. And second will be white, second color. White means 9, 29. Simply, not 2 into 9, 2, 9, 29. Into 10 over, what is the third color? Third color is green. Green in the sense 5. 10 over 5. Plus or minus tolerance. Gold is there, that's why 5% tolerance. So this is the value of a resistor. Red, white, green, gold value will be like this. That is, you can use 2920 kilo ohms. Plus or minus tolerance is 5%. Okay. This is about the value of the red, white, green, gold. So example 2. If it is a brown, black, red, silver. If 4 colors are given, what is the value? Simply, brown means 1, black means 0, into 10 power, red means 2, plus or minus, silver means 10% tolerance. That is simply 10 power 3, that is 1 kilo ohm, plus or minus 10% tolerance, ohms. So in this way you can find the value of a given resistor. So this is about the topic. Thank you for watching.